Let's do this problem from non-inertial frame. Let's place our observer inside this elevator. This is our observer. What force is exerted by block A on block B? Let's say block A pushes block B with N force downwards. So B experiences N downwards. So B also applies N on A upwards. Other forces acting on A, gravitational MAG, and because of this observer who is accelerating with this much acceleration, the pseudo force will be mass of A times acceleration of the observer. Up. This is down, so that will be up. This observer says that A is at rest. A is not accelerating according to this observer. So he says that upward force should balance the downward force. That means N plus this pseudo force should be equal to gravitational MAG. Is it enough to find N? Acceleration is known, mass is known. Yes, I think we are already done. So can you find N? And tell me how much you are getting.
Sir, N is equal to 3.9 Newton meter square.
.9 is close to 4, so that should be fine. But what about the unit? It's a force.
Newton per meter square. Oh, sorry, sir.
Answer is 4 Newton.
Newton.
Any questions? Let me know. Now this problem can be done from inertial frame also. But then you will not talk about pseudo force. So if inertial observer, Mr. Newton, considers block A, then he will talk a different language, little bit different language. He will say, Earth will apply MAG fine. There will be normal reaction N, but that is it. Only two forces are there. And he will not say that A is at rest. He will say that A is part of the lift and A is accelerating downwards. So Newton will say net force in the downward direction is this. And according to my law, of course Newton is talking So according to my law, he will say it will be equal to mass times acceleration A. You will find no difference between these two, but the way of thinking is different. Now we could also look at B, but mass of B is not given in the question. So why bother? Mass of B is not given. MB is not given. Let's now take more problems. Not based necessarily on pseudo force, but we will use whatever approach we want in solving them. Either inertial approach or non-inertial approach, whatever we like. This one has got two pulleys, light, frictionless, string is light, inextensible. Master, you can see 1 kg, 1 kg, surface is smooth. When we will get into friction, then surface can be rough also. Right now it's smooth. Calculate the tension. Calculate the tension. That's the question. String is 1 and is light, so tension should be same. And of course, pulleys are light, frictionless. Tension should be same everywhere. Now, which body should we consider? I think we will need to consider both bodies one at a time. If we take this body as our system, then it is accelerating downwards. Let us assume that. That assumption has to be correct also. A block doesn't move to the left or right just like that. Even though there is no friction, it won't move to the left or right just like that due to its inertia. So because Earth is pulling it down, only because of that it will have to move. So A downwards makes perfect sense. Net force in the downward direction, mg minus p. Net force is mass times acceleration. This body, let's take it as system. Vertical forces I'm not interested. Gravitational is there, normal reaction is there, I'm not interested. Whatever acceleration is here, same magnitude of acceleration will be to the left. Why? Because string is unstretchable. String cannot stretch. The two ends of the string, if string is unstretchable, then two ends of the string should be moving in the same manner. In same time, they will cover the same distance. So that should be A only, but to the left. So net force on the left is T, and that should be equal to MA. M and M are same, 1 and 1. So that's why same small m has been used for both of them. Two equations, two unknowns, A and T. Solve for T. See if you are getting 5 Newton. Any question, let me know. So if there are no questions, I suppose we can move on. Well, the complexity is bound to increase. In this question, this is 500 grams, this is 50 grams, this fellow is 100 grams. This angle is 30. Pulleys are light, frictionless. String is light, unstretchable. Surfaces are smooth. Find the acceleration of 500 gram block. Find the acceleration of 500 gram block. Now, when two blocks are there, one should be going down, other one should be going up. Let's just assume that this fellow is going down. If our assumption is incorrect, then we will get negative answer, no problem. So if this is A downwards, then this has to be A upwards. And this has to be A along this direction. Now, noting that all the masses are multiples of 50, I am taking that as small m. So that becomes twice m, and that becomes 10m. Okay, where m is known, 50 grams. Then there are two strings, one here and one here. And therefore, there must be two tensions. If pulley had mass, then in the same string also the tension, if pulley has mass, you need to apply some torque to rotate it. Tensions can be different. But here, pulley is light, so it will not oppose rotation at all. Just like there is inertia to maintain your velocity, there is another type of inertia, that is the inertia by which you don't like to change your rotational velocity, let's say, to make it sound easy. But that type of inertia that wants you to maintain your rotational velocity will be there if you have got some mass. If you do not have mass, you can have neither this type of inertia, what we are discussing in this topic, nor rotational type of inertia. So when we say pulley is light, it has no rotational inertia. Anybody can rotate it whatever way one wants to, without pulley posing any opposition at all. But if pulley has got mass and it is not liking when you try to rotate it, if it was at rest, tensions at the two sides can be different. Now that's a different story. Here we will have same tension as long as string is same. Same tension as long as string is same. In fact, if pulley is frictionless, then why will it rotate also? string will just slip over it. So string just slips. That really sounds funny, because what pulleys you see in movies and if you go to villages in wells, they all rotate. But that's because they are not ideal pulleys, they are real pulleys. So they have got friction. So when the string tries to pass, frictional force makes it rotate. Of course, tensions will also be different because the real pulley will have mass. But here it's really amusing. String will just slide without rotating the pulley. Frictionless, massless type of situation. Now T1, T2 everywhere in this string and in this string. We want acceleration of 500 gram block A. A is what we want. You can see several variables already. A is one variable, T1 is another variable, T2 is another variable. So mathematically speaking, we are looking at three equations up to this point. That means we should be taking three bodies, one body at a time. If we take this body first, then downward force 10 mg minus upward force T1, net force will be equal to 10 m is the mass into A. Right? Two variables are involved in this equation. Then going here, it is accelerating towards that side. So watch out for net force in this direction. That will be T1 minus T2. Right? And of course, gravitational is also there. So mass is 2m. 2 mg is acting downwards. If this angle is theta, then this component will be 2 mg sine theta. So T1 minus T2 minus 2 mg sine theta. Anything else? No. That's the net force, and that will be equal to mass times acceleration, this equation. This equation has all the three variables, A, T1 and T2. And finally this fellow, which is accelerating up, the net force in upward direction T2 minus mg, that net force must be equal to mass times acceleration. This equation has got two variables. Three variables, three equations. I don't think you should have any problem in solving for A. Can you find out A and see if you are getting 8 by 13G or anything else? If it is anything else, let me know what is it. And yes, any questions in this discussion, if you have, then let me know. So I suppose I can move on then. movable pulley. The pulleys that we have come across up to now, they were fixed. But look at this one. This is not a rod fixed to the surface, but this is a string connected to a block which can move. This is fixed. There is a support here. This support is connected to the surface. This pulley cannot move. Then this block gravity will act on it, mg force will act on it, will pull it down. This will accelerate downwards. So there will be some tension, and because of the tension this pulley would move to the right side. There will be tension generated here and this block will have to move. Note that it is a heavier block than this block. That's no problem because there is no friction. So the common thinking that it's hard to move a truck is because of friction. If truck is in space just hanging, you can move it. And by the way, one thing, in this problem, did you really need to put small m equal to 50 grams or just small m got cancelled everywhere?
So it got cancelled.
Okay. Here, this is m, this is 2m. All the usual things, light, frictionless, unstretchable. What is the acceleration of capital M? What is the tension in the string? Which string? There are two strings. Let's say this string, T1. There's a third part also. What is the force exerted by the clamp on the pulley? This clamp on this pulley. Let's first do these two. Whenever there is movable pulley, you have to be careful with the acceleration. Why is it so? It's like this. Suppose this block moves by x distance to the right. This is directly connected to this pulley. So it's same as saying that this pulley moves to the right by x. When this fellow moves by x, this pulley also moves by x. So this point comes here. Here. This point comes here. Right? When this point comes here, this much length of string plus this much length of string, x plus x. That 2x length is sort of stuck by this capital M. That 2x length is drawn by this capital M. I repeat, when this point comes here, this x plus this x, 2x length of the string moves forward and goes down. That means capital M travels 2x distance when this point comes here. This comes 2x down. So when this fellow moves by x, this fellow moves by 2x. You know that velocity is the derivative of this thing and acceleration is the derivative of velocity. So velocity and acceleration will follow the same order. Double for the right. Double for the right. So in such problems, this is the way we work, A and 2A. Actually, this is the way we work for simple problems based on movable pulley. For very complicated problems, there is another approach. This is a simple one because one can really see x and x, 2x, then 2x going down. Sometimes it's hard to see that in difficult problems, that if that is x, how much will that thing be? There can be several complications involved. So we resort to another method. So if we take this as A, then this would be 2A. Any questions? Let me know. Fine. That was the only key point actually in this question. Rest is the same story. You have to take individual systems, three bodies, that is, apply the equations. So if you take this as a system, mg is down, T1 is up. Net force downwards will be mg minus T1. That will be mass times acceleration, m into 2. Then you take this as a system. Note that there are two strings involved. One string is this big one. This is going to the support. Other string is this one. So T1 and T2 we will have to use. Now, for this, T2 is on the right side, and that's only force. So that will be equal to mass 2m multiplied by acceleration a. But then a, T1 and T2, we are having three variables. So we need three equations. But we considered movable pulley as our system for third equation. Now this pulley has got no mass. The right side T1 and T1. Left side T2. So 2T1 minus T2 will be mass times acceleration is a, but mass is 0. This will become 0. 3 equations. Can you solve for A and T1? Can you solve for A and T1? Let me know what is A and let me know what is T1.
So A is G by 3.
And T1?
So Mg by 3.
And the question was acceleration of m, and that is twice a. That means twice a is 2g by 3. 2g by 3 is the correct answer. And mg by 3 is also correct. Okay, any questions up to this point? Or we do the last part? Last part is calculate the force exerted by this clamp on this pulley. Well, take this pulley as a system. This is vertical. This string is vertical, that's important. Take this pulley as a system. One force is T1, other force is T2. You have already seen that on a massless object, no net force can act. This is massless. So the action reaction between the clamp and the pulley must be taking place, and let the reaction by the clamp be N. N should be such that it balances T1 and T2 completely. In fact, both are T1. T2 is on the left side. Here. T1 and T2 are at 90 degrees. So what is their resultant?
So root of T1 square is
root
T2
2
square.
t
Root 2t. And what will be the direction? Root 2t1.
So 45 degrees.
Like that.
the tan theta equals to 45 degrees.
Yes, we are at 45 degrees. So this angle is 45, that angle is also 45 because of symmetry. They are identical. So N should balance this force. So what should be N? Root 2 T1. And if you want the direction from horizontal, it will make 45 degree. From vertical also it will make 45 degree. Any questions? Let me know. In this question, we have a movable pulley. This has got mass 2m. This has got mass m. All surfaces are frictionless. Pulleys, strings are all light. Acceleration of capital M is what we want. Acceleration of capital M. This angle is 30 degree. This is a fixed pulley. There are going to be quite a few variables. One tension here, another tension here, then acceleration. And these two accelerations are not going to be the same because this movable pulley is involved. So 4 variables, one tension, another tension, one acceleration, another acceleration. If we can find the relationship between these two accelerations, then it should be quite convenient. Let's do it. Or maybe I can ask you to try. You can of course see the answers, but you have to tell me the explanation also. This is 2A, this is A. Why? Any problem? As we did in that question, we make the movable pulley move by certain distance. Let's say we move it up by x distance. Since it is connected to this block directly, that block will also move up by x distance. So block moves up by x, this pulley moves up by x, this point comes here. So when this pulley comes here, this x plus this x, 2x length is released, and this block pulls that 2x length and moves by 2x distance. How you think about x is entirely your choice. You don't have to think downwards necessarily. Whatever way it is convenient, you can think. Whether in reality it is in up direction or down direction is a different thing. But to find the relationship between the two accelerations, you can think of x in whatever direction, up or down, whatever you like. It is entirely your choice. So if this is x, upward is easy, I think, in this question to think. If this is x, x plus x, 2x is released, 2x is pulled down by this one. So if this is A, then that should be twice A. Any questions? Let me know.
Sir, if this movable pulley goes up, then shouldn't the direction of this 2A and A be opposite of
Yes,
what
it will
is
be opposite.
shown?
Opposite. Anything else?
Sir, and
Now.
would this first equation also change to T minus 2mg
The
is equal to
equation I have
2ma?
yet to talk about. Equation I have yet to talk about. Now, what will happen in reality? 2m block has got 2 times mass as this block. So I don't really think that 2m will go up. So in reality, 2m should be going down only. Now coming to the equation, so we will take acceleration here downwards. We will take acceleration here upwards. But even if we do the opposite, if we take acceleration here up and acceleration here down, no problem. Mathematics will take care of it. But here I have taken A downwards and just like that. Coming to the equations. For this system, if acceleration is down, then net force should be down. Net force down is 2mg minus t. And that should be equal to the mass times acceleration. I have taken this as t, one string, and this as t dash, another string. For this block, t dash mg. T dash is here, mg is here. So we want net force in this direction. Break mg into 2 components. This will be mg sine theta, if this is theta. Mg sine theta. So net force must be in this direction, t dash minus mg sine theta. That will be m times acceleration, which is 2a. Now t, t dash and a. 3 variables, one more equation. Take movable pulley as a system. Then it's light, so no net force. Upward is t dash plus t dash, downward is t. 2t dash must be equal to t. Yes, now you are asking some question. Let me know if it is not answered yet.
Sir, taking the previous case where the direction of body's acceleration was opposite, sir, would this equation be correct that t minus 2mg is equal to 2ma?
If A is up, then you will watch for net force in up direction. Then up is t minus 2mg. It will be t minus 2mg equal to 2ma. T minus 2mg will be 2ma in that case. You have got 3 equations. And the question was, find the acceleration of block M. So just solve for A. Just solve for A. See how much are you getting it.
Sir, A is g by 6 meter per second square.
A you are getting as g by 6. A is g by 6. Let me see. A should be G by 6 because the answer is
3 is G by 6.
yes. So answer is twice A. Question was acceleration of capital M, which is G by 3. Any questions? Let me know. Yes, go ahead.
Can you please explain how to find, means how did we find A that's equal to G by 6?
How did we find A? From these three equations. Okay.
Shortly.
Okay, I will tell you the procedure. If you have got three variables and you've got three linear equations and three variables, one standard simple technique is get rid of one variable out of the three. Now here you want A, so maybe you can get rid of P first of all. So make use of the third equation where T is 2T dash. So put T equal to 2T dash in the first equation. So 2mg minus 2T dash equal to twice ma. Now forget about the third equation. First and second equations, two equations in two variables. I think that you should know how to solve. Now, in this problem, we have got a big pulley, which is a fixed pulley. This is a support, I mean, it's connected to the support. This string passes over a movable pulley. And there is only one string. All usual things are there, light, frictionless, all those things. Masses are given. The question is, what is the acceleration of 5 kg block? What is the acceleration of 5 kg block? That's your assignment question. We stop now.